All right, so I want to walk you through the derivation of a present value of an annuity, which is how car payments and mortgage loan payments are calculated. So in order to understand how this formula is derived, we have to understand how the formula is sort of set up in the first place. So when you walk into a bank and a bank gives you a loan, the bank is making a lump sum investment in you, meaning they give you a chunk of money up front and expect to earn interest off of that. And then you're paying them back with what's called an annuity. And the annuity is where you put monthly payments in and interest is assessed on each of those. And they want the future value of the annuity that you're paying it back with to equal the lump sum value that they're giving you now. So lump sum investments and annuities, both at the future value of annuities, both have formulas associated with them. The lump sum formula is you take the amount of the investment, which in this case would be the amount of the loan, which is what we call the present value, times 1 plus W. W is that working interest rate again. It's the APR divided by 12, raised to the number of payments. And then the annuity formula, the future value, is the one we just derived, which is M, the monthly payment, times 1 plus W to the N minus 1 all over W. So since that lump sum investment and the annuity have to equal each other, we set those two expressions equal to each other. And if we're trying to solve for the present value, then we take this present value here and divide both sides by 1 plus W to the N. That would look like this. Now, this is a perfectly fine formula, but it's going to be a little bit easier if we do a little bit of manipulation. So if we take this 1 plus W to the N and we rewrite that as 1 plus W to the negative N, we can move that to the top of the fraction, where it gets multiplied by the entire numerator of that fraction. Now, that is now a quantity times a subtraction. So when you do that, you can distribute this negative N power thing to both of these terms. When you do that, 1 plus W to the negative N times 1 plus W to the N becomes 1 because you add those powers together and the power becomes 0. And anything to the 0 power is 1 except for 0. And then when you multiply negative 1 times this thing, it becomes minus that thing. So this is a formula for present value that you'll often see. Now, a lot of times when you go on the web, most people are interested in knowing how much they're going to have to pay per month rather than trying to have the present value when they know all the other stuff. So you'll often see this formula manipulated where the M, the monthly payment, is by itself. So to make that happen, I would have to take both sides of this equation and divide by this fraction. Now remember, dividing by fraction is the same as multiplying by the reciprocal. So when I multiply both sides by the reciprocal, I get this formula. Present value times the working interest rate divided by the quantity 1 minus 1 plus the working interest rate to the negative N power. And this is a formula that you often see used to calculate monthly payments on car loans and mortgage payments.